Okay, Math ACT Prep. Welcome to day 18. You should have your green sheet of paper with your bell ringer activity. Remember last week we did a lesson on scientific notation. So if you've forgotten how to do this, you might want to go back to that lesson in your workbook to give a little refresher on how to convert. So pause the video, take about 5 to 10 minutes and complete the bell ringer activity. And when you're done, unpause and then we'll go over the answers. Okay, so here are the answers. Remember I told you to, let me get my pen, that if you're going from, you take wherever the decimal is and you put the decimal in the new place. It's after the first non-zero number, and then you write all the numbers so you get repeating zeros. So we would do 4.375, and you write that down. It's always times a 10 to some power. This is the magic number here. And so since the decimal was here and now it's here, you just count 1, 2, 3, 4, 5, 6. So that's why that is a 6. And it's a really big number. It's greater than 1, so it's going to be a positive exponent. When it's a small number like these three, you know it's going to be a negative exponent. Big numbers, I know they're positive. This one, you would put the decimal here. It's after the first non-zero number. And we keep writing. You know, if this was to go on, we just would put a lot of zeros back here. So we do the 2.579. You have to write every single number. And then it's always times 10. And then we count. We moved it, oops, here. 1, 2, 3. So that's a -3. Now, I do want to point out there's not an example here of it, but if you had one that was like 0.3025, excuse me, you would put the decimal here and you would still write it 3025 times 10 to the 1. So even though there's a 0 in the middle, we keep writing all the numbers until there would be more zeros repeating, okay? For here to convert, literally all I would do is go, okay, 4, 3, 2. My decimal point started here, so I count 6 places because I got to make this a big number because it's positive. So 1, 2, I literally do this. 1, 2, 3, 4, 5, 6, and everywhere there's an empty space, I go back in and I fill in a 0. And then I come back and do my commas. And if I have to, like, okay, let's go ahead and write this out nicer. If this was for a test, I would make sure it's nice and pretty for my teacher. Why would I go through that trouble? Because you don't want to give a teacher any excuse to take off points. And they might say, well, I could tell if that was a decimal, and some of you did that on your last exit ticket you turned in. It looked like a decimal. You didn't erase very well. So did you erase? Did you not? You rewrite. It's clear. There's no controversy. Take the time. Here, I know it's a negative, so that means it's going to be a decimal point. So I would do the exact same thing. I'm going to draw it down here. I'd go 2, 4, 5. My decimal point's here, so I'd go 4 places. 1, 2, 3, 4. That's where my new decimal point's going to be. And I fill in all those dips with a 0. And yes, if I want to make it nice for my teacher, if I'm unsure, I'm going to write it out. Oops. Haha, I'm not even writing that correctly. That should be a 4 and then a 5. Yeah, there we go. So hopefully everybody got 100 on those. All right, so today we are moving into our next section. We're going to start talking about number quantity, absolute value, and imaginary numbers. And a lot of students want to know, why do we even have absolute value? And the reason we have absolute value is you cannot have a negative distance. You cannot run negative 10 miles. You cannot drive negative 10 miles. When we do negatives as far as the coordinate plane, negatives are directional. So if we talk about -4, then that means you're going -4 miles. You're going 4 miles to the left. +4 miles means you're going to the right. But you're still going, even if you're going in the direction -4, you're still walking, running, driving +4 miles. And again, that's the whole point of absolute value is you can't go by -10 inches length of wood. There's no such thing. So absolute value is denoted by these straight lines. This would be where in math you want to make sure that you write really, really well, because you don't want to do like, are those parentheses or are they straight lines? I don't know. So I always make sure when I do mine, when I do absolute value, I overemphasize because I get going really fast. And if I get going really fast, they'll have some curve to it. And then I question whether it's a parenthesis. So I keep my parentheses short and I over exaggerate my absolute value. Why do I over exaggerate the absolute value and not the parentheses? I don't use absolute value very often. I do parentheses all the time. So when we do absolute value, again, we're wanting to know the length regardless of the direction it's going. Negative and positive tells us whether we're going right or left. It probably went the wrong way, or whether we're going up or down on a coordinate plane. Okay, we just want to know how far away from center is that point or that line from 0, 0. So here, try these. So if you're at a restaurant or you're standing somewhere, we're downtown Nashville and you're standing at a point and you look up a restaurant on your phone and it says it's 2 miles away. But it's on the same street you're on. So you're standing on the street, and if it's on the same street and it's going this way, then it could be 2 miles that way, or it could be 2 miles this way. Which way? Could be either one. So let's sketch out what it could look like. So if you're standing there, you could be going 2 miles to the right. You could be going 2 miles to the left. But either way, you're going to be walking +2 miles. You're not going to put in your pedometer, like if you're tracking how many steps you had, you're not going to go, oh, well, I went -2 miles or -2,000 steps. So instead of doing 10,000 steps today, I only did 8,000. No, you did that many steps. So this restaurant could be to the right or left side of where you're standing. And so that's where, usually with the phone, the GPS is use the coordinate plane. And if it's -2 miles, then you're going to be going to the left. If it's +2 miles, you're going to be going to the right. That's going to tell you the direction in which to walk. So again, we're looking at being on a number line or being on the coordinate plane, and how far are you away from 0? So if we're looking at this example, where you're standing is 0. How far are the 2 restaurants away from you? Each one of them are +2 miles away from you. The -2 one just means it's to the left of you. The +2 one means it's to the right. But they're both 2 miles from you. So when we get this expression, the absolute value of 2, you've got to know that there's 2 values. It's kind of like x squared equals 16. You've got to know that x can be positive or -4, because -4 times -4 equals +16, as well as +4 times +4. When I see an absolute value, I know there's always 2 answers. There's a positive and a negative. So here, absolute value of x is equal to 2. So that means x can be -2 or +2, because absolute value of 2 is 2. Absolute value of -2 is 2. That's just kind of something to put to memory. When you're taking the square root of something, it's the positive and the negative. When you're finding the absolute value, you've got two answers, a positive and a negative. So if we're looking at this equation here, and these tend to throw students off, they're saying solve for x. Now, for those of you that are struggling right now, that you're like, oh my gosh, I have no idea how to do that, I want to change this equation a little bit. I want to change it to be this. And usually when I do this, the light bulb goes off. Everybody's like, oh, well, that's easy. Then that means that x is either equal to +5 or -5. And I'm going to go, you're 100% correct. And they're like, yay, but I can't do this one. Well, if you just did this one, you can do that one because this is the same thing. Whatever this comes out to be is the same as this. It's got to equal +5 or -5. So you're just going to set up two equations, okay? You're just going to set up two equations. You're going to make this 3x + 1. It has to equal +5. And it also has to equal, I don't set it up like this. I do, I set it up like this. 3x + 1 equals -5. This makes more sense to me than this does. Yeah. So then we solve over here. You subtract 1 from both sides, divide by 3. So one value is x equals 4/3. The other one, I'll do my math over here so that you can see it. We subtract 1 from both sides and we get -6. When I divide both sides, I get -2. And again, this makes more sense to me because I know 3x + 1 has to equal positive or -5. So my two answers here are x equals 4/3 and x equals -2. When x is 4/3, what's inside here will equal +5. When x is -2, what's inside here will equal -5. Now, imaginary numbers. This tends to be an Algebra 2 thing. So this is going to give you a little leg up before you get to Algebra 2 next year. And what is an imaginary number? Basically, you cannot take the square root of any negative number. Can't do this, okay? So if I have, say, the square root of -16, I can't solve that. But because people have done really, really complex problems, they have figured out that maybe along the way you might get something like this that I can solve because -16 times -1 is going to give me the square root of +16, which gives me a perfect answer of 4. So what they have done in math is they have come up with this imaginary number, and the imaginary number is I. This is why we never use I as a variable, and I is equal to the square root of -1. So if we were to look at this right here, we could rewrite this as the square root of -1 times the square root of 16. I can take the square root of 16, which is 4, and this is I. So this answer would become 4i. And if later down the road in the math, I somehow divided by an I, then the answer would be a 4. And when you get into complex math, that's what happens. So that's pretty much what a imaginary number is it allows us to account for that square root of a negative number. Now, when you have a complex number, that is, where we're having like that 4 times I, that makes it complex because we've got two different types of numbers. The other reason too is when you have I squared is going to be -1 because what is I squared? If I is the square root of 1, then I squared is going to be the square root of -1 times the square root of negative 1. Negative 1 times negative 1 is positive, so this equals the square root of 1. Or sorry, no, the square roots cancel each other out. I'm not even thinking. The square roots cancel each other out, so the answer is negative 1. Yeah, there we go. And then this is something that you don't necessarily have to have memorized, and actually, hint for the exit ticket, you should not. This is not something I want you to memorize when you do the exit ticket. If you copy this chart, it will be counted 100% wrong and you will get a 0. You will get a 0 if you give me this chart. This chart is identifying when we have I squared, I to the third, and I to the fourth, what the numbers are. And this is one of these two right here are the reasons why we do imaginary numbers. Because when we get I squared or I to the fourth, basically any even exponent, we can get a legit number that we can work with. When they are odd exponents, we're kind of still stuck with an I. But when we get squares and even numbers, we can actually come with an actual number. But again, you shouldn't memorize this because you should be able to go, okay, I is equal to the square root of negative 1. So if you want to know what I squared is, then that means it is square root of negative 1 times square root of negative 1. And when you do the square root of a number times the square root of the same number, that just equals negative 1. You should be able to figure this out on your own. And I cubed, okay, totally forgotten what it is, but I know that is the square root of negative 1 times square root of negative 1 times the square root of negative 1. And I already know that square root of negative 1 times square root of negative 1 is negative 1. I got this guy left over by himself. Well, that's an I. So it's going to be equal to negative I. That's the best I can do. And then if you get to I to the fourth, then you know it is square root of negative 1 times square root of negative 1. Sorry, this is really hard to draw. Square root of negative 1 times square root of negative 1. Well, we know these two give us a negative 1 times these two give us a negative 1. And what is negative 1 times negative 1? Positive 1. So again, I don't need to memorize this. If all I know is this right here, I should be able to use my knowledge of exponents and figure out all the rest. Yeah. Okay, so pause for a moment and I want you to try to figure out this ACT example involving absolute value. Okay, let's see if you got your answer right. Hopefully everybody did. The big question is we need to work here first. And when we do 4 minus 9, you're going to get what? 4 minus 9 times the absolute value of negative 5. Now here's where students make a mistake. They will multiply here and get a positive 20 because they go, ooh, negative times negative is a positive. No. You have to do the absolute value first. And this is going to be negative 4 times the absolute value of negative 5, which is positive 5. So our answer is negative 20. Hopefully y'all got that. Okay, practice time, 6 questions. Set your clock, set your stopwatch, set your timer in your kitchen, and practice. Ready, set, go. Okay, everybody's back now. Let's check these answers. Hoping for 100 from everybody. And if not, at least you figure out what you were doing wrong. So absolute value here. Again, we want to work inside the absolute values first. So 8 minus 2 is 6. So we want to do the absolute value of 6. minus, what is 2 minus 8? That is negative 6. Do an absolute value. So now I'm going to get rid of my absolute values. So what is the absolute value of 6? It's 6 minus, what's the absolute value of negative 6? It's 6. And this equals 0. Yeah. Now this one here, what are the real solutions to the equation? Absolute value x squared minus absolute value of x minus 6 equals 0. Some of you probably know, ooh, I could factor this. You can. You could set this equal to 0, and you could factor it into the absolute value of x. Absolute value of x minus 3 equals 0, and then the absolute value of x plus 2 equals 0. But the problem is then you got to plug them all back in. That's just going to kind of tell you your answers are 2 or 3. But 2 ends up not working. When it's absolute value, you got to kind of test them. So that's not a good approach to this. The best approach here is to take the answers and plug them in. And I do look here, and my first thought is, ooh, let's try 2 and 3. And since it's absolute value, you usually have a solution that's the positive and negative of a single number. So I kind of know it's probably not going to be these. Yeah. So I'm probably going to I might try 2 first. The book says work from the middle and out, so I'm probably going to go 3. And when you plug in, the positives usually always work. It's the negatives. I'd start with the negatives first. So negative 3 here is going to give me positive 3. And then I square it. Minus, what is negative 3? That's going to be positive 3. And then minus 6. So you're going to get 9 minus 3 minus 6. That equals 0. Yes. When you put in the 2, you're going to get 4 minus 2 minus 6. That doesn't work. Here, this is one of those problems where they give you the variables and they don't give you anything else. And I have told you before, when they give you this, assign a value for x and y. It makes it easier. So they say x is less than y. So absolute value of x minus y is equivalent to which of the following? Well, let's work smarter, not harder. Let's let x be equal to 1 and y be equal to 2, because y's got to be greater. So let's do this. Absolute value of 1 minus 2 is going to give me what? 1 minus 2 is negative 1, so it's going to give me 1. Okay? Now take these numbers. What is 1 plus 2? That's 3. Does not equal that. What is 1 plus 2? That's 3 times the negative. It's not that one. What is 1 minus 2? That gives me a negative 1. Take the square root of it. That gives me I. Can't do it. What is 1 minus 2? Negative 1. It's not that one. I'm going to double check, make sure it's E. What is 1 minus 2? Negative 1 times a negative, positive 1. And again, pick a value, because if you try to think abstractly like that, you'll spend hours. Here, what is the solution set for the following equations? Again, they're just asking for answers. Okay, so let's draw this up. Here, let's do a number line. And there's 0, 1, 2, 3, 4, 1, 2, 3, 4, 5. So we're sitting here at negative 2. This is negative 2. And they want to know which ones are 3 units away. Let me change color. Make it look a little easier. So here we go, 1, 2, 3, and that is sitting at what? 1. And if we go here, 1, 2, 3, then that's sitting at negative 2, negative 3, negative 4. This one is sitting at negative 5. So I know my answers are -5 and 1. Okay? Those are the two numbers that are 3 units away, right and left of -2. So basically, you just go down here and plug them in. Which one works? -5 plus 2 gives me -3. Absolute value equals 3. 1 plus 2 is +3. Absolute value is 3. Ooh, this one works. -5 minus 2 gives me -7. Absolute value does not equal 3. That's out. -5 plus 3 gives me -2. When I take the absolute value, you should know this one. When you take the absolute value of anything, it's not negative. -5 plus -3 gives me -8. Absolute value of 8 or -8 does not equal 2. -5 plus 3 gives me -5 plus 3 gives me -2. -2 does, absolute value of -2 does equal 2. So it's either F or K. Now let's try the ones. 1 plus 2 is 3 equals 3. 1 plus 3 equals 4 does not equal 2. All right, the next one. Ooh, this one, a lot of people get this one wrong. This goes back to algebra. This goes back to foiling, and this is one of your special cases. This is your A minus B squared, which equals A squared minus 2AB plus B squared. Sorry, I can't write that well. So you can FOIL it out, or I know this is going to be 36 minus 12I plus I squared. And since I know that I squared is equal to -1, I squared is equal to -1, then I can substitute this for -1. So then 36 minus 1 gives me the 35. Now, this next one, I love this next one because I read it. Yes, I've taught math. And I get into this, and yes, this is geometry, but until Common Core, I'd never really heard modulus, all this stuff. I read it, and I'm sitting here going, I have no idea. Yeah, I get eyes, I get complex number, modulus. What are you asking me for here on the graph? I don't have a clue. But when I see this right here, it looks familiar. Looks very familiar. It looks like Pythagorean theorem when I'm trying to find C. That is, when you find C, that is the square root of A squared plus B squared. It's hypotenuse. So I'm sitting here going, okay, does that mean they're wanting me to create right triangles from the center, which is exactly what they're asking you to do, and tell you which hypotenuse is the longest? Which one's the longest? Z1. And again, like, that's easy. You look at the graph, Z1, obviously, it's the longest, but they've worded it in such a way that it just makes your head spin. But if you'll just notice, look and see what's familiar. Square root of A squared plus B squared. Okay, that's Pythagorean theorem. That's when I'm finding the hypotenuse. Okay, which one of the hypotenuse, which one would be the longest is Z1. You end up being right. Okay, so now you should complete the video. You should do your exit ticket and turn it in. Sorry, I'm looking for the exit ticket so that I can, here it is, give you hints. I already gave you a hint on this. It was earlier in the video. If you put the chart, you are not going to get a good grade. You just copy that chart from the workbook, I'm going to count it wrong. Because I don't want you to memorize the chart. I want you to tell me how, if all you remember is I equals the square root of -1, how you can apply that and know what I squared is, what I cubed is, what I to the fourth. Again, hint, was it earlier in the video? Might need to rewind, watch it. Kind of wrote it all down. Yep. So that's what I want to see here, because that's what you need to remember, not the chart. All right. Happy math day. Happy hump day. Enjoy your day. Get all your work done. And I will see you Thursday or Friday.